Hello and welcome to a Learn Conversation. My name is Silvija and my guests today are Charlotte Dupont and Geir Lasse Taranger. Charlotte is Executive Director and Co-founder of Biocenor at Sophia-Antipolis in the south of France. And Geir Lasse is the Research Director at the Institute of Marine Research, Havforskningsinstituttet. Welcome.
Thank you.
Thanks.
It's lovely having you here in this series that we're doing with NCE Seafood Innovation. I'm just going to say a few words about the series and then we'll get started with the conversation. So this is a series of inspiring and educational storytelling conversations where the National Center of Expertise, Seafood Innovation, is focusing on their work on data smart fish farming with special focus on salmon. We have spoken with people about the general strategy and the technicalities of sensors, and we have spoken with some of the suppliers focusing on AI applications, etc. In this conversation, we are going to talk about environmental data in specific focus and how they can be a factor for success for fish farming and perhaps management of our oceans in general. Does that sound okay?
Yes, perfect.
Excellent. So my first question is always, who are you and what has made you so? This conversation is, people listening in to our chat without ever having met any one of us. And the whole story is much more interesting for them if they know a little bit about who they are listening to. So maybe we start with the ladies. And Charlotte, please tell us a little bit about yourself.
Hi. Thank you. So I am Charlotte Dupont. I am a co-founder of Biocenor, a French company in the south of France. So I'm French. I have started this company 2 years ago with my husband. And this company is focused on water quality analysis and prediction. So we are trying to analyze the water parameters that we gather with the sensors and try to make some insight of it. And moreover, with the prediction, where we can anticipate the evolution of the water quality, and we can give some information about what is probably going to happen in the next hours.
And you don't do this only in ocean water, you can do it in any kind of water, or can you just tell us a little bit about your market?
Yes, so we have a big market in aquaculture because aquaculture in open waters is really relies really on the environment with the weather forecast and things like that. So it's really our first market, but we also can do it in outside environment like lakes, rivers, coastal areas where the ecosystem are very sensitive. So we can also try to understand how it is impacted by the changes in the environmental data and how we can maybe provide some help on that.
Very cool. I have to ask you one more question. I think you answered it very professionally, so I have to try to get to know you a little bit more personally. Do you have any weird hobbies?
Weird, no. I like to dive because I really like the oceans. I like nature, so I like to hike. But also I'm a bit of a geek, so I like to code and make some informatic applications. It's one also of my passion.
Very cool. I will have to invite you here and test. I live in Fornebu, which is just outside Oslo, by the sea, and the innermost end of a little bit of the fjord that goes in here, and the water has gone from saline to fresh almost, and it's very shallow, and there are very, very kind of big changes in the bottom, and it's shallowing all the time. So it'd be really interesting to see somebody who can help us explain what's happening with our water.
Yeah, with a great pleasure. It's really what we like to do.
Great. And Geir Lasse, who are you?
Yeah, hi. So currently I'm a research director with responsibility for aquaculture and technology and environment at the Institute of Marine Research in Bergen. But right now I'm back in my home place in Austevoll, which is a tiny island outside Bergen, fishing and aquaculture community. So when I was just embarking on my studies, we had a fish farm here, salmon farm in the pioneering days. So I did my summer job here. And that's where I catch up with this interest for salmon farming. And been having a quite long career working with salmon, cod and other aquaculture species. But now it's also much about the modeling and trying to use environmental data to improve our models. And on the hobby side, later this evening, I'm going out kayaking in this fantastic weather we have in Austevoll today. So I'm looking forward to that. And I will probably see a few fish farms on the way in the kayak as well.
Wonderful. I just have to ask you a dummy question again. Why is Norway so very focused on salmon in its fish farming? Is it history or?
Well, you could say we have tried to develop several species since the, let's say, late 70s. And we have a research station here at Austevoll at the Institute of Marine Research, where we have developed other species like the Atlantic halibut, the Atlantic cod, scallops, blue mussels, wrasses, and so forth. But it's in Norway, it turned out that the salmon was the most, let's say, easy fish to farm in the net pans. It could be several reasons for that. One thing is that they are born in freshwater and have big eggs, and when they are like 100 grams, we can put them into these sea cages. But like some of the other species, like the cod and halibut, are much more difficult when it comes to the brood stock and with the eggs and larvae. So although we have had big progress, it has been a much longer story to get those species going. So the salmon is very suitable as a farmed fish, but also a very good product, of course.
And then my second dummy question. I'll get to environmental data in a second, I promise. But I'm just fascinated. Is the fish quality or the quality of protein and everything else essentially any different in farmed fish? Because there are all these people who insist on buying wild and saying that it tastes differently. Can it? Does it?
Well, so at our institute, we cover the entire value chain from ocean environment until seafood quality and also impact on human health. And as of now, actually, the farmed salmon has less contaminants compared to the wild salmon. And that's because, of course, we have the control of the feed of the farmed salmon. So there's no need to prefer a wild salmon compared to a farmed salmon when it comes to quality and the beneficial value as far as I am concerned.
I'll remember that. So I am wondering about your education, and I can't really see. Both of you have a PhD in biology, but one of you said salmon's physiology. That's maybe it's not you.
That's me.
That's the Norwegian.
So what I did when I did my master and my PhD, I was working with salmon and developing or understanding how the environment impact the physiology of the fish, which is of course important for the welfare and health of the fish. So by knowing how the environment interacts with the fish, we can provide a better environment taking care of the welfare and also the health of the fish. So also it will grow well and so forth. So and in a way, salmon now we have really a lot of knowledge about this species, not only because of aquaculture, but it has been studied also from a wild fish perspective for more than 100 years. So it's one of the fish species where we have most knowledge.
Mm. Fascinating fish also with this whole freshwater part of its life. And Not far from where I live, there is I don't know if it's a trout or a salmon, a staircase, or I don't know what you call them, but basically a really, really high area they have to jump their way through. And it's amazing fish that they know what to do.
Yeah, if you consider, for example, in particular the salmon, the sea trout, they also migrate from the freshwater to the fjords and stay mostly in the fjords before they return to the river, whereas the salmon have these phenomenal migrations as far as to Greenland, and then they find their way back to their home rivers. It's quite amazing how they can navigate to get there. So it's still something we really don't know how they can manage to do that. There are many theories, like they are using maybe some magnetism, maybe they can use the water quality in a way. We really don't know exactly how they manage to do this incredible migration.
I guess they have their own environmental data sensors. And now we are approaching, Charlotte, the topic of what is environmental data. And so I'm thinking, my first thought is meteorology, but that's not it, right? Or
no, it's bigger than that. In the case of water, there is so many physical chemical parameters that you can have in the water measured, and you can have the oxygen level that is really interesting because fish needs oxygen to survive, and sometimes there is some events that lower the oxygen and fish has to react to that. So the oxygen level is, for example, one of the environmental data that we can follow. There is a lot of other parameters like the pH of the water, for the acidity of the water. There is also the turbidity of the water, which is the transparency, in fact. So it can be an indication of nutrients that can be available or not in the water. So this kind of parameters is really interesting to follow because it can really change very quickly or very slowly, depending on the events. And the environmental parameters in the water is not only the weather, but of course the weather has an impact. Sometimes we can follow the currents, so we can know if some nutrients can come from some place or not. We can follow even the rain is interesting because the rain can lower the salinity of the water a little bit. And this little shift can really have a lot of consequences on the composition of the water and the nutrients availability and things like that. So it's the weather a little bit, but it's also the chemistry of the water. Yeah.
And this is important because as the chemistry of the water changes, for example, suddenly there can be an onrush of lice or algae or...
Yeah, exactly. The algae, for example, they need oxygen to, they need oxygen, so they can really lower the oxygen level in the water. And so when there is many algae, like we call the algae bloom, then it's really not good for the fish and for the salmon because they have less oxygen because the algae take everything. And so, yeah, we need to follow. One of the project that we have also is that we try to anticipate this algae appearance. And so if we can anticipate this algae appearance, maybe we can have some changes in the production so the fish won't be impacted by the oxygen drop. So it's really interesting.
But just a question there. So I'm having these pictures in my mind and I think so would you want to basically put something in the water that removes the oxygen so that the algae disappears, or would you want to guide the algae out of the way and the way? Or what's the good treatment?
No, actually, it's very difficult to get rid of the algae because once they are there, it's very difficult to get them out. It's better to act on the fish production And maybe, for example, when there is algae bloom detected, really act before it's too important. Try to adapt the feeding method, because the feeding method can really impact also the oxygen level. Try to harvest before, because if the fish are already very close to harvesting, if you harvest before, then you can avoid losing the production when the algae comes. But once they are there, for the moment, we don't have any solution to make them go away.
What do you think, Geir Lasse?
Yeah, so I think one of the features of the salmon farming in Norway, when it comes to the seawater part, they are mostly in these open net cages at the coast, and then they are exposed to everything that's in the water. And sometimes, not so often in Norway, I have to say, we have these harmful algae. But by and large, it's not the biggest problem. But when they appear, they are a really big problem. But there are other hazards in the sea as well. And currently, maybe the biggest showstopper in salmon farming is a parasite called the salmon lice. And the salmon lice is a natural parasite on salmon and trout here in Norway. But with the fish farming, let's say the balance between the parasite and the fish has changed, and that has become a big problem. So one thing is to use environmental data, and for example, the water current, which is also important, to find out how these parasites are distributed from farm to farm and also to the wild fish. Also, you could also use environmental information to if there's a hazard coming, you could, to some extent, affect the production, for example, by using barriers like skirts or features that would actually minimize the influx into the cage of, for example, harmful algae. But as mentioned, that's a really tricky one to combat. There are some new technologies also developed, like semi-closed cages, but they are not very common yet. So
what does it mean?
Yeah, that means so a classical salmon farm is really open. So it's just a net, so the water is flushing through, which is really good for the oxygen that was mentioned. So the fish need the oxygen, but when there is some harmful thing in the water, it's not so good anymore. So if you could then have more like a canvas or a solid tank and pump the water from the depth, you could avoid it. But that's not really yet a very normal way of producing salmon in Norway. So then another way to sort of mitigate the problem is to be able to predict the environment, as was mentioned here, and maybe take some actions beforehand, so you can at least be prepared for problems that occur. But of course, these environmental data that can be collected in the cages are important for very many things. Certainly for the welfare of the fish that are in the cages, and also it's important when it comes to how one fish farm are affecting the next fish farm, for example, through the water currents. So
because it could spread.
Because, for example, these parasites, they can spread from one farm to the other, and also there can be viruses and so forth that can go with the water current. So on the one hand, by knowing the environment, you can take better care of the fish, and that's also good for the neighbor, you could say.
So my question now is, how do you gather the data? I mean, I've heard about these cameras that can, 360 cameras, etc., and a lot of data can be gathered about the fish by now. But gathering all this environmental data, is there a little box I could put in the water that would feed me with all the sensor data I need, or what would be a recipe for me if I was a fish farmer?
There is the sensors. Actually, you can set up sensors. So we provide sensors, but there is a lot of other companies that provide sensors. Very interesting sensors can be also put outside of the cage, not only inside the cage, but outside of the cage, so we can see what is going on outside, what is coming through, what is going out. So this is very interesting. But also we use the satellite data. Now it's more and more used. It's something that is easier to have and to analyze as compared to 10 years ago, for example. And so with the satellite data, we can have more information about, for example, the chlorophyll level in the sea. That is an indicator of the algae. We can have, of course, information about the water current very precisely, and it has really been a good help in the last years now, the satellite data.
Yeah. So adding on to that, so a little bit of the complexity is, of course, that the environment changed very much from the top of the water column and deeper down. So you would also need sensors that can actually go up and down in the water masses, or you would have a whole array of sensors, or you could also have robotics to that would actually patrol the environment. So we at the Institute of Marine Research, we are investing in what we call gliders, which are very energy efficient robotics that can dive up and down in the water column and then collect these key environmental data at the different depths. And every time it's up, it can send data back by a satellite, for example. And within the farm, you could they could go up and down all the day and night, and monitor, for example, how well is the oxygen, and which is so important for the fish welfare and also for controlling the feeding, as was mentioned here. So I think having more of these sensors, either within the cages and also around fish farms, are really important for taking care of the welfare of the fish.
Going back to the welfare of the fish, one of the examples that was used before was this depth of fish population or community inside the pen. What determines that, and why is that important?
So one of the things we found some years ago is that, for example, this particular parasite, the salmon lice, typically are very in the shallow part, very high up in the water column. And so if we can monitor, for example, by echo sounders at the swimming depth of the fish, and also you could modulate that by, for example, feeding deep in the cages, or by using artificial light that you put further down in the cages, you could actually separate, in a way, the salmon from this parasite just by making sure that they stay deeper down in the cages most of the time. There are also some particular cages called snorkel cages, where actually there's just like a big tunnel up to the surface, so the salmon can swim up and grasp some air, because they need that for balancing their swim bladder. And then most of the time they stay really deep down in the water. Also, these echo sounders can be used to monitor how the fish respond to feeding, if they are hungry or if they are actually satiated. So the fine thing with echo sounder is that its sound travel much easier. It's much easier with sound than with the image. Having said that, of course, also image analysis is very important. For example, here in Norway, it's mandatory to count the number of this parasite you have on the salmon on a weekly basis in each cage. And now with the use of with the camera technology and artificial intelligence, you can actually do this job more precisely and continuously compared to doing it manually, which is also, of course, hassle for the fish to take it out of the cages. So using modern image analysis technology is also a really important tool in this part.
I have to admit that the level of technology sophistication related to fish farming, at least the stories I've heard here from Norway, actually exceeds my dreams. So I was very curious to hear from Charlotte the international perspective of this. So AquaCloud is a Norwegian initiative, and any value to you internationally to participate in a data gathering set like this?
Yeah, it is very interesting because also we have this data standardization process into AquaCloud. So it is very interesting that everyone in all regions of the world can have the same language, in fact, when coming to water data and aquaculture data. It was not, there are no standard before for aquaculture. So people have its own language in the Mediterranean Sea or in the Norway. So with this initiative, it is very, very interesting to have this common standard. And also the technology in the other part of the world is not as much as Norway. I think in Norway is really there is a lot of technology in the fish farm, and people really understand why they need to have this technology and what it will bring to them. But what I can see in the Mediterranean region, where I am now, it is more complex to make them understand the real power of technology on a fish farm. Generally, they have this father to son experience, and they rely on that, and they know because their father did that before, and they don't really need to have, for example, environmental data information. So it is really important to evangelize the need of technology in fish farming, and how it will really help them to improve in the production, also be more sustainable, because you can control what is going outside of the farm. So I think in the other part of the world, it's really coming now, but it's not as much as developed as in Norway.
Also, I think that so in Norway we have seen a dramatic, let's say, development of this salmon farming in cages since the early 80s, where the cages was much smaller, and maybe it was hand feeding, and you had sort of visual contact with the fish. Relatively few fish compared to today. Today, with really big cages, it's very difficult to do it in that way. So you're really depending on technology and camera technology, echo sounders, and environmental profiling. Yeah. But one interesting feature that I think will also come from artificial intelligence. So one thing is when we use machine learning to make a computer to do the same stuff as we do, basically by training with some known objects. But I think also by using artificial intelligence, you can actually pick out patterns that would otherwise be difficult to quantify. And that could maybe be more similar to this father-to-son transition of what we call this unspoken knowledge that you gather by over a long time. So it's also very interesting to see how these, not only the sensor technology and the collaboration between farmers like they do in this AquaCloud project, but also the artificial intelligence could actually open up some new boxes for us that could actually identify patterns that we would otherwise not see.
Actually, it is exactly exactly why we have been invited Biocenor in AquaCloud project. It was to try to make some algorithm on the data and see what it can bring with machine learning. Exactly, if we can see patterns that is not easy to see with human eyes, and actually the results are very good, because we can really see some things that it's difficult to see with human eyes.
Now, just 2 points I want to underline in what you just said. So the first one was about this development of fish farming in Norway, I think that we underestimate the value of infrastructure. So, the accessibility of good bandwidth networks, of all this camera technology, of all the computing power, which has become a commodity in this country. I think that that's a very good innovation platform. And when you describe, this transition from small pens, hand feeding, visual contact, that's how I imagine fish farming. And then I hear you talking about something that sounds more like, a Houston control center. And I think we are getting closer to the solving the paradox where we knew more about the surface of the moon than the bottom of our oceans. It seems like, we're figuring out a lot going on under there in the deep unknowns. And then the other thing I just want you to comment on, both of you actually, is the role of farmers in all of this. Because on one hand, you could think that these people would be scared and thinking, well, is AI going to take away my fish farming job as well? Am I not going to be allowed to be a fisherman even? On the other hand, what you were just saying, both of you, is that it is the combination of the tacit knowledge and the interpretation of the data that's really important.
Yeah, I think maybe we are in a transition now, and one thing was this transition from small cages on protected sites, hand feeding, visual contact, which is quite a few years ago. And then we have had these big, let's say, cages and with platforms where people are sitting out on this platform using video cameras and so forth and controlling the feeding. The next step we see now is that this is centralized. So one office at land actually often can monitor a lot of farms by using not only video cameras in all the cages, which is of course important for feeding and so forth, or echo sounders or other stuff. So you actually are moving back, the decision making away from the site, which could be threatening, you could say. But I think also now there's a kind of so you get these hubs where actually more people are actually collaborating across sites. So there's kind of two-step development. First, we had sort of this where everything was still on the site, but using a lot of technology. Now it's a new step where actually they are centralizing at least the feeding control, but also we were speaking about fish welfare and health earlier on, which is really important. I remember when I was doing this summer job here out in Austevoll, it was at that time of the year that the fish diseases turned out, and you had to really have a good eye to pick up the first fish that became ill and then have all the mitigation things. Now you get another way of sharing knowledge and discussing. So I think there are also some beneficial things with this centralizing. But so it's I think it's an interesting time now in Norwegian fish farming. And then you put on top of that the new technology. So it's actually on the move right now as we speak.
Charlotte, what should we in Norway bring in from the international data and international development?
I think what we talked earlier about machine learning and artificial intelligence is really the key now, because in Norway there is a really good level of equipment and technology. But now using this technology to anticipate better, to take better decision based on this machine learning and artificial intelligence tools, something that's growing all over the world. I think it will really bring a lot to fish farming in Norway, because it will help to make better decisions, to feed at the right time, to be more sustainable, to have better welfare of the fish. So it will really bring a lot to fish farming in Norway.
So going towards the end of our time here, I just want to ask you about the connection between environmental data and environmental sustainability. So, there is obviously efficiencies for fish production and fish welfare. But are you also helping with, generally keeping an eye on the environment, especially in the sea?
So one of the features here in Norway is that environmental sustainability is really high on the agenda for fish farming. And I mentioned this problem with this salmon lice parasite that is currently maybe the biggest issue. And in this case, it's also really important that the fish farms collaborate to solve the problem. And by using models and the data we are speaking about here, they can help each other and actually find a way to solve that really important sustainability issue. Because one of the things that regulate salmon farming in Norway now is the impact on the wild salmon. And in order to do that, they need to have these good models in order to both tackle, let's say, acute problems here and now, but also to do planning to how should we have a more smart way of collecting the sites. You could use these models also for scenario testing, so to see what would be the right strategy ahead to minimize these environmental impacts. And also, of course, many of these data are also important for other environmental impacts, such as how you affect habitats around the cages, like corals or other habitats that are really sensitive to the input from fish farming. So combining sensor data with good models, I think is really important also for the sustainability issue for salmon farming.
And also it can be done only because now we have a lot of information coming in with the sensors. It's generally real-time sensors that gather with information continuously. Several years before, it was not as frequent. So now we are beginning to gather a lot of data, environmental data, and with that we can do good models, we can do good prediction, good advice, and see really the impact on the environment. So it is also one of the key.
A time perspective here as well. Both of you have been working on this for some time, and Geir Lasse longer than most. Do you see some practical effects of the climate change through your environmental data?
So at our institute, we also have a big focus on how the climate change is affecting the ocean, both in terms of course, temperature and ocean acidification. But one of the interesting things for fish farming is the renewal of the deep water in the fjords that are also impacted by the climate, and also, of course, the freshwater runoff from the rivers. That it was mentioned that rain is important, but overall, the freshwater input to the fjords are really important. So I would not say we can, as of now, say precisely how the climate is impacting fish farming, but certainly when we look ahead, it will be an important factor. And one thing is this freshwater runoff that will probably then be different and affecting the environment in the fjords, but also the renewal of the oxygen in the fjords and thereby the carrying capacity of the fjord. So we see a few fjords in Western Norway where actually the renewal of this deep water, which is not where the salmon is, but in the bottom, is now so low in oxygen that they have to move out fish farms. Having said that, it doesn't mean that the fish farms was the first problem here, but with this, when the water is renewed not so often, the capacity goes down. So that's probably one of the impacts we could see in some of the fjords. But most of the coast in Norway is still with very good water currents and good renewal. So this is limited to some fjords only.
So in the south of France, we have a big problem with harmful algae bloom. I think bigger than in Norway. And I think that it's because also of the heat of the water that is getting higher in the summer. And every summer we have records of temperature that is higher and higher. And we have oyster farming in the south of France. We have fish farming and etc. And it's really impacted by the algae bloom. This is the only impact I can see now, but there are many, of course.
Can I ask you, for humans, I mean, we go swimming some of these places and see the algae and generally don't like it, but does it matter in any way?
It depends on the species of the algae. Some algae are toxic. They can really release in the water toxic compound. So then you cannot swim. But some doesn't do anything except impacting the ecosystem by using all the nutrients, lowering the oxygen. But for humans, it's quite okay, even if you don't like to swim in this kind of water.
And I think this is, when it comes to the harmful algae, this is one of the topics where we can learn from other parts of the world, because that has not been a really big issue here in Norway up until now, but that could become worse with climate changes in the future. And we see, so like 2 years ago, we had this massive bloom up in the north of Norway that killed a lot of fish, maybe because of some particular meteorological conditions that affected them. And we are now at the IMR installing equipment using, again, image analysis to identify harmful algae. And that will be combined with satellite imagery, with data from all the fish farms and so forth. So I think we have to be prepared that this could become a bigger issue also here in Norway in the future. Right now, it's not really so often we have a problem. And I think it's very seldom we see problems for humans, at least. But of course, the fish is more exposed than to this. But typically in the spring here in Norway, you see that the water goes from blue to almost green, and that's because of algae. But they are normally not toxic, or they are not harmful at all. So you see, so this color you see in spring is the algal bloom, but most of them are really not a problem at all.
Yes, it's true. It's the most common are not toxic.
I think perhaps if we find a way to eat the most common that are not toxic, we could solve the problem both ways. So going towards the end, I just want to read your quotes or life mottos. I think both of them are wonderful. Charlotte wrote, "Be yourself and choose your own path." And Geir Lasse said, "It's too late to be pessimistic now." Any personal aspect or reflections on that?
Yeah, so I think I'm a great believer in knowledge and in collaboration and also in technology. So I think we can achieve a lot of improvements if we collaborate, if we keep on focusing on solving problems and providing with a good knowledge base. Then I think we will have, we can see a great future of aquaculture both in Norway and globally.
Pessimism is not an option, basically. And you, Charlotte?
Yeah, for me, it was inspired by my own experience because I am a scientific. I have a PhD. I have done some academic research. And then I created my own company. And a lot of people say it was impossible, that a scientific cannot do it. And so if you listen to everyone, you don't never do anything. So that's why it was. Choose your own path and be yourself.
Thank you both so very much for a very inspiring and rich conversation.
Okay.
Thank you.